Thank you so much for the presentation. Now, I would like to invite Victor Ojotisa to make his presentation about cement replacement with glazed brick powder and paving blocks. Hello, good afternoon. Thanks for the opportunity for this present. My topic is waste brick powder and paving blocks. I would just like to start with, as we all know, waste right now in the world is something we're trying to fix. So we're trying to mitigate the waste we have as landfills are filling up and discussing some environmental, some negative impact on the environment and also humans as well. So I'm going to do a brief introduction, talk briefly about the waste break, concrete paving block itself, material methods, result discussions, my conclusion with some recommendations. Like I said, concrete is one of the fundamental materials we use right now, globally, all around the world. Everywhere you look around, there's always concrete. But the production of concrete has some negative impacts on the environment, such as CO2 emissions, which affect the ozone layers, etc. So we're trying to find ways we can mitigate this by reducing or either replacing parts of the concrete, and by one of the methods we used was trying to use some waste. Waste brick, for example, was what we used for this particular project, and roughly 950 kilograms per day is the waste produced, such as scrap waste brick and going to show a picture. So we use that for this project. Waste brick itself is also part of it is part of the cement modified soils or cement treated base, etc. I'm going to talk about it. Waste brick itself, sorry about that, but I'm going to show you it in another figure. We're going to be using fired waste brick for this project. We're going to crush it and make it very fine at 150 micron. And like I said earlier on, roughly 950 kilograms per day is the waste that is generated per day. So you can imagine how much is generated per week or in months or in a year. And North Cyprus majorly has two production companies which we use to estimate this value. This is the picture of the waste brick. As you can see, it's scrapped, so this can't be used, but this is basically waste. We use this for paving block because, for example, paving block is now the main structural component. It's a non-structural component, and so we use it because we can use it for pedestrian walks, kit parks, etc. And they are good products. They sustain loads. I'm going to put out the provider, and they are skid resistant as well. So, like I said earlier on, we use them for pedestrian areas, driveways, even your garden, etc. And you can also design them to be in a certain texture or color depending on what you want to use them for. So we have some brick types, but the type for this project that we focused on was concrete paving and block paving. There's some type of paving blocks. Some also occur naturally like limestone. There's a Portland paving. There's walling. Like I said earlier, this block paving is going to be the type we use. And this is a more pictorial definition for the surface. So some benefits of the concrete paving include for the performance, application, reconditioning, reinstatement and cycling and aesthetic. For performance, its strength is really good. For its application, like I said earlier, for pedestrian walks, for your driveway, for your garden, etc. Reconditioning, reinstatement, and recycling. I'm going to group these three together. For example, if there's a damage in one of the blocks because of the way it is put together, you can section it in a way which makes it an easy fix. So fixing it is not costly. So recycling as well, you can, when you degrade it back, you can include it back into a new batch. Aesthetics, like I said earlier on, for color, for design, you can use it. So waste brick was collected from the production companies here in Cyprus. We use the jaw crusher. I'm going to show a picture that shows this process. We use it to crush it to bring it down to a more fine state. Then we use the Los Angeles to break it down to 150 micron. Then we did the chemical composition as well for it. We're using XRF. So this is the first stage. Then we broke it down to this. Then we use the jaw crusher or miller as it's called Then we use the Los Angeles machine. Then we broke it down to 150 micron. This is the chemical composition of the waste brick, and this is the graph showing the aggregate we used. So I'm going to show you a table after the slide that shows the percentage we did. We made sure we did everything. We kept the water ratio constant. I'm going to show you soon. Then we use the vibro compaction method. For this project, we made sure we did it the same way the paving blocks, the steps, the way it's done industrially, we did the same method, just to try to copy the method to get the similar values. So this is the table I was talking about. We have our water binder ratio, we kept it constant. Our main cost and fine cost as well, kept it constant. Due to our percentage for fine cost, so the sample came out dry because there was no surface to cover. So this is 0% or 5%, 10% waste brick replacement sequentially. Based on this picture, you can see on the surface that it's a bit dry. So these are the results that were obtained. We obtained after 20 days, 10% replacement was the optimum. And for density, there was a continual degree. For the compressive strength, it's really good because it's improved. And for the density, we can look at it in terms of when you want to transport your samples. It will be light, so your foil, you save foil as well, because foil is another aspect, but that's another topic that we're trying to conserve. So in conclusion, like I said earlier on, there was a considered decrease in density, but 10% was our optimum. And some recommendations that could be made would be, for example, for this, we only after we demolded it, we only sprayed it once and kept it for 7 days or 28 days when we did the testing. So a recommendation could be that it could be either sprayed continually for 3 days or thereabouts, or it's totally immersed, like a proper concrete sample. And we could also do microstructural analysis to see the interaction between both the waste brick and between the samples itself. These are some of